Oh, was it recording?
Yeah, we're good.
Okay, better cut that.
All right, so welcome to demo 4 of Intro to Backend. Today we're going to be continuing on from Monday's demo, where we'll be making our to-do app again, except for using abstractions and ORMs as opposed to raw SQL code. So last time we implemented this task class and subtask class over here. And so now with ORMs, we can implement these as objects, and using object-oriented programming, we need to specify that these are db.models, because models are the blueprint for how we build an entry in our database. So in our task class, we have an ID, description, done, and subtask fields. And in our subtask class, we have the ID, description, done, and task ID fields. And as a reminder, the subtasks and tasks fields are foreign keys that reference each other for a one-to-many relationship. So now what we're familiar with is calling a function in our database for app.py and kind of using it to query data from the database using raw SQL. But now since we're using ORMs, these are actual Python objects. So we're going to do something different in our app.py file. So first we're going to do our get tasks endpoint. So we're first going to create an empty tasks object over here. And the next thing that we'll do is write this thing called for task in task dot query dot all. So what this basically does is that, as I said before, in previous demos, we usually had like a get all tasks function in our database file that executed a raw SQL query to get information from the database. But now, since we're using SQL Alchemy, SQL Alchemy actually has built-in functions to help us query information from our database. And this task.query.all function basically gets all of the data from our task table. And so this literally means for every task in all of the tasks in the database, we append it to our tasks variable. And then at the end, we just return a success response as we generalized up here. And that's going to be, we're going to return our serialized, or sorry, my bad. So in tasks.append, we have to serialize this task object because it's not in a nice format. So we'll do task.serialize, and the serialize function is what we made down here that serializes a task object into a nice dictionary for front end. So we have task.append, task.serialize, and then we return a success response of a dictionary, which would be tasks, and then this is just tasks, and then our response code would just be 200. And since it's the default parameter over here, we don't need to specify anything. Okay. And yeah, that should work. So now we can go test this on Postman, but first we have to get our terminal or our virtual environment running. So let me do that real quick. So we have the virtual environment created. Now we're going to activate it. And then lastly, we're going to run the server. Oop. Oh, I forgot to install requirements.txt. There we go. And then now we can run our app just fine. And so we can go test this on Postman. We have a route over here for get all tasks, and move this out of the way. We send it, we see that we have an empty tasks object since we haven't inserted anything into the database yet. So another way we can write this get tasks function, there's a better way we can write it in terms of syntax. So instead of doing this, let's just comment this out for a second. And so we're going to write this like so. So we're going to say tasks equals task.serialize for task in task.query.all. And so this is some special Python syntax that you can use so that it basically has a for loop. And so for every task in task.query.all, we serialize it and we're adding it into this list. And so this is going to be some very useful syntax that we're going to actually use later in the other functions. So yeah, we can try and test this again. Oh, let's see. Oh, I forgot to return the success response. All right. And yeah, that should now work. So this is much cleaner syntax to write this get tasks function. And like I said, we're going to be using this later in the demo to write some other stuff. So yeah, so the next thing we're going to want to do is create a task. So we're going to, I guess, fill in this method over here. So we have some sort of body that we're getting from front end because it's a post request. So we're going to have body equals json.loads request.data. And then we're going to say, we're going to instantiate a new task object since we are representing tasks as objects. So we're going to say, we're going to have our new task, and that's going to equal new task, I guess, object. And we want to make sure up here that we're importing task and also subtask. And then lastly, another thing we want to import is request. That's going to come up later. Or actually that's going to come up right now because we have to load the request.data. So make sure you have these 3 imports up here or else it's going to result in some errors. So back to here, we have a description, and that's going to be our body.get description. We have a comment here, and then we have done equals body.get, and then done. And then so now we have this new task, but now we have to update the database since we just made changes in it. And again, I guess in the previous demos, we had this self.con.commit function that we used in db.py. But since we're using ORMs, SQL Alchemy has functions to, I guess, update and add stuff to the database. So the first thing we're going to want to do is this thing called db.session.add new task. And what this basically does is it adds the new task to our database. And then now that we've added it, we need to save the changes. So we're going to do db.session.commit. And then this basically saves the change that we just did in the database. And then lastly, we're going to want to return this new task that we just created. So we're going to return success response, this new task. And remember, this new task has not been serialized, so it's not in a good form. So we're going to want to serialize this. And then since this is a post request and we're creating a task, we're going to have a response code of 201, which is going to override the default parameter of 200 over here. So let's save that and go test it on Postman. So we have create new task over here. So we have description as exercise and done. Let's have that as false. And let's send this in. And we see that a new task has been created. So let's go to get all tasks. And we see that we have a new task over here that's been created with an ID 1, description exercise, and done equals false. Okay. So the next thing we're going to want to do is fill in the get task by ID function. So this get task function over here. In the previous demo, we implemented this function by calling a database function that had a raw SQL query again. But again, SQL Alchemy has functions that queried the database for us. So we're going to write here is we're going to have our task that we're trying to get. So we're going to have task equals task.query dot filter by, and then we're going to have our parameter, our ID is our task ID. Make sure you have this ID equals over here. If you just have this, it's going to result in some errors. So make sure you have the ID equals. And then we're also going to do dot first. And so the reason why we have dot first is task.query.filter by, it technically can return multiple tasks. But in this case, since each task ID is unique, since it's our primary identifier, we're only ever going to get one, I guess, task returned by this thing. So calling first on an object that has one task is just going to return that task. But it's good you're going to need this first, just in case if it returns multiple tasks for any odd reason. So now that we have our task, we have to check if it's none. So if task is none, then we're going to return a failure response. So like task not found. And we see that our default parameter is 404. So we don't need to put anything over there. And then so if we do have a task, we're just going to return success response. And that's just going to be our task, except it's going to be serialized to a nice dictionary. And again, it's a success code of 200, which is up here. So we don't need to put anything as a parameter in there. So let's save this and see if it works in Postman. So we're going to do get task by ID. We have our URL and then a 1 over here representing the task that we want to get. If we send this in, we see that it returns the task that we created a minute ago. So now the next thing we want to do is, I guess, update a task. So let's say I actually did exercise today and I want to set this to true. So now we're going to want to fill in this update task function over here. So the first thing we're going to want to do, since this is a post request, is get the body of the request. So body equals JSON.loads request.data. And then we have, so next we're going to get the task that we're trying to get. So we're going to have task equals task.query.filter by. And then we have our ID is our task ID. And then we have dot first at the end here. So first we're going to check if this task is none. So if task is none, return failure response, task not found. And then if it is indeed something, we're going to set our task dot description equal to the body dot get description. And if for some reason we didn't include, I guess, a description field in the body of our request body, we can just keep this as the original description of the task. So what we can do is have a comma here and have an extra parameter task dot description. So basically, again, what this does is if I send in a Postman request, if I say done equals true and there's no description, then the description will still be kept as task.description or the original one. So then we're going to set task.done equal to body.get done. And then if we are not updating the done field, we just have task.done as the original field. And then since we made a change to our database, we have to again say db.session.commit. And then lastly, we're going to return a success response, which is going to be our new task serialized. Okay. So let's go test this in Postman. So let's review. We have get all tasks. We have one task over here. So let's go over here to update a task by ID. So post request. And so let's say done is true. If we send it in, we see that done is indeed true. So if we do, let's test our get task by ID again. We're going to see that this has turned back to true, which is a good sign that we're on the right track. So the next thing we're going to want to do is update this delete task function. So yeah. So the first thing we're going to want to do, since we have a task ID as a parameter, is again, try and check if the task actually exists. So we're going to have, again, task equals JSON.loads request.data, task equals task dot, oh, my bad. Task equals task dot query dot filter by, and then our ID is our task ID. And then we have it as first. And again, if our task is none, we say failure response that our task is not found. And if it indeed is something, so I guess in the previous demo, again, we had a function like delete from task table that had like a raw SQL command that kind of deleted stuff from the database. But again, since we're using ORMs, SQL Alchemy has a function for that. So we can use this command db.session.delete. And then if we pass in the task over here, that's just going to delete the task from our database, which is pretty nice. And since we just made a change to our database, we have to commit again. So db.session.commit. And then lastly, we want to return the task that we just deleted. So we're going to do return success response or task serialized to a dictionary. And yeah, so let's go test this on Postman. So we see that we have one task in our database. Let's go try and delete it. We see that it's returned this task. So we see that it should be deleted. And we have an empty tasks object over here. So let me just create this task again for future reference. Okay. Yep. Okay, so now we're going to want to fill in these subtask routes. So remember that subtasks are in a one-to-many relationship with a particular task. And we've already modeled this since we have a foreign key in our task and subtask class. So like over here, we have a subtasks field within our task model that is in a relationship with this task ID field over here, which is a foreign key. So yeah, so then, yeah, we can go ahead and code up the create task endpoint. So we're going to go over here. We're going to say, so we have a task ID over here. And so we're first going to want to see if this task actually exists. So we're going to do task equals task dot query dot filter by. And then our ID is our task ID. And then we say dot first. And then our task is none. Return failure response. Task not found. If it does indeed exist, we load the body of the request. So body equals JSON.loads request.data. Then we have our new subtask that we want to create. So let's store this in the variable new subtask. And this is going to be a subtask object with these certain fields. So the first thing we have in our subtask class is a description. So we're going to say description equals body dot get description. We have a field called done. So we're going to do body dot get done. And then lastly, we have a task ID. And so this is going to be a little different since we're just going to set this to task ID because our task ID is passed in the URL. So we're not getting it from the body, we're actually getting it from the URL. Okay, there's something with my AirPods. That's all good. All right, yeah, so we have this new subtask. Question, yeah.
Yeah, so for the one that you're working on right now, the new subtask, you're getting the body description, body done, and all that. Can you use like double star body instead?
Double star body.
Or
Comes from requested.
what? Keywords are used instead.
Oh, okay. So for keyword arguments, that's only in the init function. So I guess with routes and stuff, you have like a request coming in, and that's how you're getting your data. When you're actually initializing like the stuff over here, this keyword arguments only goes in the init function over here. But yeah, so that's why we do that. Yeah, we're all good. Okay. So yeah, now that we have created this new subtask, we want to add it into our database. So we're going to do db.session.add, and we're going to add this new subtask into our database. And then we're going to want to save this change. So db.session.commit. And then lastly, we're going to want to return this new subtask. So return success response. And so remember that we also have a serialize function for our subtask model. So we're going to do new subtask.serialize. And then we're going to have a response code of 201 because we just created a new subtask. And yeah, so let's go test this in Postman real quick. So we have a new subtask. So description is run, and I haven't done that, so false. We're going to send this in, and we see that it's been created. So if we go to, or we can't really see it in get all tasks. So if I hit get all tasks, right, it would be kind of nice if we could have some kind of subtasks field over here to see which subtasks are part of this task, right? So we see that when we created this has a task ID of 1, but we can't see that. Hold up. Oh, it's over here. Yeah. So we see that this has a task ID of 1, and it's associated with this task over here. So it would be nice if we could see which subtasks are part of a task. So this is the next thing we're going to do. We're going to change the task model so that we can actually see the subtasks that a task currently has. So I go over here. You have to. Yeah. So we're going to go in our tasks model over here, and for our serialize function, we're going to. Okay, yeah. So what we're going to want to change in our task model is we're going to want to include this line over here. I think I accidentally included it in the last demo, but this line over here, subtasks equals db.relationship subtask, and then cascade.delete. Cascade equals delete. This kind of represents the relationship with the subtask, and we use this command. And the first parameter is going to be the name of the class that we have a relationship with. So task, the class task is going to have a relationship with the class subtask over here. And so we're going to have, I guess, our first parameter be capital S subtask over here. And then we have this next parameter called cascade equals delete. And what this basically means is that, let's say you have a task and you have a bunch of subtasks with it, right? And let's say I delete this task from our database. The kind of like logical thing to like happen is that when you delete that task, you want all of its subtasks to also delete when you delete that original task. So this is what cascade equals delete does. It kind of, when you delete a task, it deletes all of its children or subtasks. So yeah. Well, for the purposes of this class, you're actually probably not going to want to. So yeah, we just leave it as delete. I think if you want to keep the subtasks, you just like not have this field, I believe. But yeah. Okay. So yeah, and then the next thing we're going to want to do is, like I said, in Postman, we couldn't really see the subtasks of a task. So we're going to have to update the serialize function in the task to actually like see the subtasks. So what we're going to do is we're going to add this extra field called subtasks. And then using the syntax that we just learned up or over here in the get task method, this syntax, we're going to be using it again over here. So we're going to say s.serialize for s in subtasks. So what, or self.subtasks. So what this basically does is that for every subtask in subtasks over here of a task, we serialize it and we store it in this kind of list over here so that when we do serialize a task, we can see all of its subtasks. So you can save this, go back to Postman. And if we say get all tasks, we go over here, we see that we have this new field subtasks, and this over here is the subtask that we had. So it's run and false, and this aligns with the task that we just had over here. So now that we just demonstrated a one-to-many relationship, we're now going to write code for some many-to-many relationships. So we're going to model a many-to-many relationship between tasks and, let's say, categories. So we're going to have one task have the possibility of having many categories, and also one category have the possibility of being associated with many tasks. So since we want to create this category, I guess, entity, we're going to want to create a category class. So that's the next thing we're going to do. So we'll say class category. And again, since this is going to be a model, let's just say db.model. And then this is going to be our category model. And so again, when making a class, we want to have a table name. And so our table name is just going to be category. And then, so some fields that we're going to want to have in this category are, of course, an ID. So we're going to have db.column. And then this is going to be an integer. We're going to want this to be the primary key of this model. So we're going to set that to true. And then we're going to set auto increment to be true as well. Next field we're going to have is a description of this category. We could say, again, db.column. This is going to be a string, and we're going to want this to be not null. And then lastly, we're going to have a color field. So like if I have, I don't know, if I associate my task with some category, it's like a red category, you could say color equals dot column. Again, this is going to be a string. And again, nullable will be false, so it's not null. So the next thing we're going to want to do is, I guess, have a way to initialize like a category object. So we're going to have to define the init function for it. So it takes itself as a parameter. And this is going to initialize a category object. Again, we're going to have our self.description just be equal to, oh, my bad. We also have the keyword arguments over here that you mentioned up there. So yeah, we have keyword arguments. So we're going to have keyword arguments dot get description. And if the description is not provided, we're just going to leave this as the empty string to preserve the not null functionality. And again, self.done, we're going to have keyword arguments dot get color. And yeah, so that now that we were able to initialize a category object, we need also a way to serialize it so that we can see kind of like what its attributes are. So we're going to define this next. So define serialize. It's going to take itself as a parameter. Oh yeah, self.color. Yeah, good catch. Yeah. Okay. So yeah, going back to serialize, this is going to serialize a category object. And so we're simply just going to return, I guess, the attribute of a category as dictionary. So we're going to have an ID be self.id, description be self.description, and lastly, a color be self.color. So now that we have this category class, we need to set up the many-to-many relationship between task and category. So if you remember from Monday, the way to do this is via an association table. So this is what we're going to be creating next. So I guess to remember, an association table is like when you have a table with two columns, and one column is going to reference the ID of one table. So let's say the task table, and then the other column is going to reference the ID of the category table. And so those two are both going to be foreign keys to those two tables. So to create this association table, we're going to go back up to over here, up in the file, and we're going to type in association table equals. This is going to be a db.table. And so we're going to have two columns. So first it's going to be db.column. So this is going to be named task ID. This is going to be an integer because our IDs in our task model are integers. This is going to be a foreign key to the ID field of the task table. So again, this column is called task ID. It's an integer, and it's a foreign key that references the ID field in the task table. So then we need to create another column that's going to be referencing the ID field of the category table. So we're going to name this category ID. This is going to be another integer. It's going to be a foreign key that references the ID of the category table over here. Does that make sense to everyone? Yeah. So now that we have the association table, we actually have to go into each of our models and classes and actually define the many-to-many relationships between tasks and categories. So over here. Okay, yeah, thanks. All right. Yeah, so then we have to go into our class models and actually like edit some fields or create some new fields over here. So in our db.py file in the task class, under this subtasks field, we're going to create a new categories field. And again, this is going to be a relationship with the category class. It's important to note that this is the name of the class and not the name of the table. So this is going to be capital C for category. And then we're going to have this thing called secondary equals association table. And so what this does for us is that it defines this association table that we made above as a reference point for our many-to-many relationship. So basically, like, we created this association table, and then having this as a parameter allows us to actually refer to it. So this is why we have that. And then we're going to have this field called back populates equals tasks. So basically what back populates does is that this field allows us to make a bidirectional relationship. So like if we make a relationship in one direction, then it's going to make another relationship in the other direction. So for example, if I add task X into category Y, then SQL Alchemy will know that category Y corresponds to task X. And in the tasks field for category, there should be task X in it. So we haven't defined it yet. But by having back populates be tasks, SQL Alchemy is going to understand that there's going to be a tasks field over here, and if we add a task to it, it's going to automatically add it to this tasks field over here. Yeah. Does anyone have any questions? Okay. Yeah, so then we're gonna do the same thing in the category class. So we're gonna go over here and we're gonna say tasks equals db.relationship. This is going to be referencing the task class. Again, we're gonna have our secondary be our association table, so we can actually like create this many-to-many relationship. And then lastly, we also have back populates be true, so that when a category is associated with a task, let's say task X, the categories field in task X should include this new category, if that makes any sense. So by having back populates over here and back populates down here, whenever we add, I guess, a task to a category and a category to a task, these fields automatically get updated to include that relationship. Okay. So the last thing we need to do in the db.file, and it might be helpful to visualize like which categories a particular task belongs to when we serialize a task object. So this will let front end know like which category our task belongs to. So we're going to edit our task.serialize function over here. So what we're going to say is categories, and we're going to say c.serialize for C in self.categories. So again, this is the syntax we learned earlier. For every category in the categories field, we serialize it and we append it to this list over here. And similarly, we can try to do something in the categories serialize function again, because it might be helpful to know like which tasks are part of a category. So if we try to have tasks is t.serialize for T in self.tasks. So initially this looks fine, but you may notice that it might create an infinite loop. So let's say that I try to serialize a task, right? And so we get through here and we end up hitting this categories thing, right? So c.serialize, we're going to serialize every category for, I guess, the task, right? So when this function is called, it's going to jump back to over here. And so it's going to serialize the ID, description, color, but then it's going to hit tasks. And so since it's part of a task, it's going to try to serialize the task again. So this is going to like jump back and forth forever. And this is going to create an infinite loop. So one possible solution for this is to have a different serialize function that does not include the tasks for the categories. So we can call this new function simple serialize, since it doesn't have the tasks field over here. So we're going to define a new function, simple serialize, and this is going to serialize category object without the tasks field. And so we're simply going to return the ID is self.id, description, self.description, and the color is just self.color. And if we go up here in the tasks serialize function and we instead say c.simple serialize, we get rid of this like infinite loop problem that we just had. So now that we finished with all three classes, we can finally go implement this last route over here, which is going to be assigning a category to a task ID. So in this endpoint, we're going to have two things to consider. First, we have to look for the task. And then the second thing we have to look for is if a category actually exists. And if it doesn't exist, we're going to want to create a category. But if it does, we're going to want to, I guess, keep that category and just assign the task to it. So the first thing we're going to want to do is actually look for the task. So we're going to say task equals tasks.query.filter by ID equals task ID, and then dot first. If our task is none, return a failure response. If it does indeed exist, then we get the body of the request, which is sent in through, I guess, our route over here. So body equals request or JSON.loads request.data. Our description going to be our body.get description, and our done is going to be body.get. Or sorry, our color is going to be our body.get color. And so now we're to the point where we need to see if the actual category that we're actually assigning to actually exists. So let's write some documentation here. Going to create a new category if it doesn't exist. Otherwise, assign existing one. Okay. So the way we're going to do this is we're going to try and find this category, right? So we're going to say category equals category dot query dot filter by, and we're going to filter by the color. So we're just going to say color is color, and we're going to again say dot first. And I see that this is not recognized, so it means I have to import it at the top. So it's going to be up here. Scrolling back down, we have our category. And so if our category is none, then we're going to want to create this new category, right? So we're going to have category equals category dot, or not dot, instantiate, I guess, a new category object. So description equals description, and our color is equal to color. And then if it actually does exist, then we already have a category over here, so we don't need to worry about it. So now that we have our category, we can go over to task.categories.append. We're going to append the category. And then since we made a change to our database, we have to do db.session.commit. And then lastly, we return a success response that we indeed assigned a category to our task. So we're going to serialize our task. And okay, so now we got it working. So yeah, so we have get all tasks, which is our task over here of exercise. And so let's try to assign a category to this task. So let's say our description is run and our color is red. And so we see that we have created a category over here for this task. So if we go to get all tasks, we see that we have something for subtasks, and we also have a new thing for categories, which is this category that we just created. So if you wanted to assign a new one, we just say swim, and we could say this is blue, and then send this in. And then if we go back to get all tasks, we see that we have two categories for this one task. So again, the thing that caused this was not having this syntax over here. I'm honestly not sure why that is. I ran this before, and these two lines over here seem to work just fine for me before, but I guess just having these things over here, I guess makes it work. So yeah, okay. Yeah, so I guess with an association table, or I guess with this table in general, like we have a table name over here, and then I guess some type of metadata over here. And then I guess our two columns that we have are task ID and our category ID. So yeah, so we filled in all the routes, we got all the classes. So I think that's pretty much it for the demo. And then Let's get to the Kahoot. Yeah, does anyone have any questions?